A vertical plate is submerged, partially submerged in water. With the shape, approximate the hydrostatic force against one side using the Riemann sum, then set up the integral and evaluate it. The thin plate is partially submerged in water. We only find the hydrostatic force for the part that is submerged in water. We need to slice the thin plate horizontally so that any point on the slice has the same depth from the water level. We then position the coordinate axis so that y equals 0 is at the water level with the positive direction pointing down. The depth of the slice is yi. The force on this slice is rho g a d. Rho g are constant, d is the depth, a is the area of the slice. The depth is yi and the area is the width times the thickness, but the thickness is delta y. Note that the width of the slice depends on how far below the water level the slice is. And so the width is the function of y. There is a linear relationship between the width and the depth. When the depth is -1, the width of the slice is 4 on the top, and when the depth is 1, the width is 2 at the bottom of the trapezoid shape. The width is a function of y, w equals L of y, where this relationship is linear because the side is a straight line, whose slope is 2 minus 4 over 1 minus -1, which is -2 over 2 or -1. We can also see that the initial width when y equals 0 is 3, or we can use the slope-intercept form. W equals -1y plus b. Plug in 1 for y and 2 for w. We have b equals 3. And so the width is L of y equals -1y plus 3, or 3 minus y. The width L is a function of y. That the force on the slice is rho g yi. The width is now 3 minus yi, and the thickness is delta y. This is the force on one slice only. The total force is the sum of the forces on all of the slices. We add these up from I, go from 1 to n, rho g yi, 3 minus yi, delta y. There are n slices. As n go to infinity, we obtain the definite integral. We add up the slices from y equals 0 to y equals 1 only. Rho is 1000, g 9.8, yi is now y, and 3 minus yi is 3 minus y. Delta y becomes dy. For the limit of integration, the lower is 0 and the upper is 1. We simplify this definite integral. 9.8 times 1000 is 9800, which is a constant, so we move it to the front. Evaluate this integral. We will get 11,433.33. The unit is newtons.